Happy snow days, so here's some benchmark 2 review answers for you. Which statement is incorrect for the graph y equals -3 cosine of pi over 3 times x minus 4 plus 7? So, is the period 6 pi? Well, to find the period, we take the number in front of x called the frequency, and say the frequency times the period will give us 2 pi. Well, times 3, pi p equals 6 pi. So p equals 6. The period is 6. That is a true statement. The amplitude is 3. Well, it looks like it's -3, but the amplitude is really just the number there. The negative is actually a reflection. So the amplitude is 3. That is true, so that is not the answer. The range is 4 to 10. Well, I have a midline here of 7, and from 7 I'm going up 3 and down 3. So yes, my range is from 4 to 10. That's a true statement. The midline is y equals -4. No, it's y equals 7. That -4 there is actually a shift. Which direction is it? Well, it's the opposite. That's shifting right 4. That's what that phase shift is on the inside there. If the terminal side of an angle theta in standard position passes through the point -4, 3. So I've got an angle passing through the point -4, 3. There's my angle there. What is the numerical value of cosine? Well, first of all, I'm in quadrant 2. And in quadrant 2, my x values are negative, my y values are positive. This is sine's quadrant, sine's positive. So I want the value of cosine. I'm not picking one of these positive answers. That's first off the bat. I'm down to a 50-50 guess now, if I have to get to that. Draw my triangle back to the x-axis. I went -4, that's a -4, up 3. So, using the Pythagorean theorem, I get 3 squared plus 4 squared equals the hypotenuse squared. Well, if 25 equals c squared, that's 5. So the cosine of theta, here's my reference angle in here. Cosine is adjacent over hypotenuse. I get -4, -4/5. Know how to solve problems like this where I give you some information and you need to find me the values of trig functions at that given angle. Graph 2 cycles of the function here, 4 sine of 3x plus 2. Well, I have a midline at y equals 2. That's the first thing I've got to take care of. I've got a midline here at y equals 2. There it is. From that midline now, I am going up 4. 1, 2, 3, 4. Make sure you mark that. 2, up to 6, and down 4 to -2. It's a sine curve. You need to know what sine looks like. Sine is little hill, little valley. So I'm going to start at my midline, go over a box max, midline, over a box min, midline. There's my sine curve. One cycle of it. I have to label where that one cycle ends. What x value did I land at? It wasn't 4. My frequency is 3. So the period is 2 pi over 3. The period is 2 pi over 3. That means it takes 2 pi over 3 to get through one full cycle. Well, I need to do this again. So max, middle, min, midline. And if I was using my pen, I'd have a beautiful curve here, but I only have my finger to use because my pen is at school, so I apologize for my sloppiness here. That's it. That's how we can graph trig functions using midline, amplitude, frequency, and period. Some complex number work. Simplify xi times I minus 7i squared. Well, following our order of operations, we have to do that squaring before we deal with that multiplication. So if you didn't notice the trick here, you had to make a table. Instead, I had I minus 7 times I minus 7i. I minus 7i times I minus 7i, which gives you I squared, -7i squared, -7i squared. Negative times negative is positive 49i squared. And going through this process, you said, warning, 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 I squared is -1. So I have -1 plus 7 plus 7 minus 49. And this all comes out to -36. So that blue box that I just highlighted there is actually the real number, -36. So it's xi times -36. So I'm going to write my answer as -36xi. That's my final answer. You have to be able to perform complex arithmetic with complex numbers, multiply, adding, and subtracting them. And knowing that I squared equals -1 is the essential piece. Solve algebraically for all values of x. Well, I see a polynomial equation sitting in front of me, so I'm going to set it equal to 0. So I'm going to add over 32. Now, before I try to factor this, I'm going to say, wait a minute, there's a GCF of 2 here, so let's take out a 2. If you didn't take out this 2 now, you would have had to take it out later in the problem. But I think it's the easiest just to take it out now. I've got 4 terms, and 4 terms means I'm grouping. From the first 2 terms, I can take a GCF of x squared out. For my second 2 terms, I need an x plus 4, so I have to take out a positive 4. Don't forget that plus there. So my factors are x plus 4 times x squared plus 4, and that 2 is out front, equals 0. This is perfect squares, but it's the sum of perfect squares. It's kind of like the difference of perfect squares. It's kind of like it, but I need a complex number there. I need that I there to make that positive happen and not a negative happen. So these are all my factors. Remember, we can factor the sum of perfect squares by using these complex numbers. So, using the zero product property now, I can get all my solutions are x equals -4, x equals -2i, and positive 2i. Those are my zeros. Number 6, the solutions to this equation are, well, I've got a quadratic equation, and I see a plus or minus and some square roots and complex numbers. That's key that I have to use the quadratic formula. So before I use the quadratic formula, though, this needs to be set equal to 0. So 0 equals positive 1/2 x squared minus 6x plus 20. So the quadratic formula goes x equals -b, the opposite of b, plus or minus the square root of b squared, which is 36, minus 4 times a times c, all, I'm a little behind, 1/2 times c, all over 2 times a, which is really 1. So when you type that under the radical, the discriminant under the radical into your calculator, you get 6 plus or minus the square root of -4 all over 1. Luckily, I don't need that all over 1 because dividing by 1 is silly. Well, what's the square root of -4? Well, the square root of 4 is 2, and we made up that complex number I by trying to figure out what is the square root of a negative number. So it's 6 plus or minus 2i. Choice 3. Number 7, the expression m squared over m to the 1/3 to the -1/2 is equivalent to, so this is practicing with our properties of exponents and dealing with fractional exponents and their connection to radicals. So when I see this, the first thing I'm going to start is on the inside. I have a division, so I'm going to subtract those exponents. This is going to be real fun. 2 minus 1/3. Well, 6/3 minus 1/3 is 5/3. Please use your calculator, folks, and hit math frac. So I've got m to the 5/3 to the -1/2. So I've got a power to a power, and now I have a power to a power. I multiply the fractions, which gives me m to the -5/6. Well, a negative exponent throws me in the denominator. I take the reciprocal to deal with that. So I have 1 over m to the 5/6. And because I have that 6 there, that over 6 in my denominator, that tells me I'm taking a 6th root. That 5 is still just an exponent. 1 over the 6th root of m to the 5th. So 1 over the 6th root of m to the 5th. Write an equation of a parabola that has a focus of -2, -3, and a directrix of y equals 1. So, sketch the picture. I have a focus at -2, -3. That's the focus. A directrix of y equals 1. So the first thing we do is find the vertex who's in the middle. How far apart are those? Well, they're 4 apart, so I need to go up 2 to that point of the vertex is -2, -1, because that's in the middle there. The parabola's got to be concave down because the directrix, I can't cross through that. Okay, so now I have to write the equation y equals something squared. It's a parabola. Well, to get to this point here, we care about the vertex. I have to go left 2, so x plus 2, it's the opposite of the x value. The y value is the same. To determine the leading coefficient, you figure out the focal length. How far apart is the focus and the vertex? The focus and the vertex are 2 apart. And this is that weird thing that it just came out from the distance formula, that if I want to figure out that leading coefficient, I multiply that by 4 and flip it. So 2 times 4 is 8, flip it, 1/8. But because the parabola is concave down, I need a negative. Make sure you practice looking over these problems. That would be in Unit 3 towards the middle, if you want to look over some videos practicing these problems. And finally, number 9, knowing x minus 2 is a factor of f, find all zeros. So x minus 2 is a factor. So I know I can write it as x minus 2 times something. I have to figure out what that something is, and the way that I'm going to do that is divide. I'm going to divide to figure out what that something is. So I got an x cubed and negative 8x squared, 37x negative 50. You can use long division as well. What times x is x cubed? X squared. That gives me negative 2x squared, so I need negative 6 of them to continue on. Minus 6x, positive 12x, so I need 15 of them to get 25 of them to get to 37. So 25x. I have a 25 up top, which gives me a negative 50. I get a remainder of 0 because it is a factor, so we're good. So I now know that it factors as x minus 2 times x squared minus 6x plus 25. I could try to factor this by asking myself, what multiplies to 25 and adds to negative 6, and you're going to get nowhere. So we have to use the quadratic formula. But before we do that, if x minus 2 is a factor, x equals 2 is one of the zeros. And now we get to quadratic formula to figure out the zeros from this. So x equals the opposite of b plus or minus the square root of b squared minus 4 times 1 times 25 all over 2 times 1, which is 2. So we get 6 plus or minus. In my calculator, I'm typing in 36 minus 4 times 1 times 25 and getting the square root of negative 64 all over 2. Well, the square root of negative 64, that's a perfect square there. That's 8i all over 2. So my final two zeros are 3 plus or minus 4i. Those are my other two zeros. It's an x to the third polynomial, so it should have 3 complex zeros. I have 2, which is a complex number, 3 plus 4i, and 3 minus 4i. Make sure you study for this benchmark and know how to do these problems cold, because they will be helpful for the questions you'll be encountering in the benchmark. Maybe I'll see you tomorrow. Maybe we won't. Who knows?